Well, Asian carp particularly, it's been the last 6 months, but I've been working with fish for over 10 years, especially with trying to increase or develop approaches to increase the commercial value of underutilized species, including Asian carp, byproducts from the fishing industry. That's basically what I have been doing for the last 10 years.
And from here on out, I would say we're just kind of a show and tell. Kind of talk me through what do we have here today and what are we going to be doing as part of your research.
Okay, so we have, what we're doing is we're working with, in this case, Asian carp, and as I said, we're trying to develop approaches to increase the commercial value of an underutilized fish. What we're going to do is we get the Asian carp, we cut it up, we fillet it, and we take out the meat, which we have some over here, for example. And then if Jason is going to help us blend that meat with water. And what we are trying to do is we're trying to homogenize the sample, or muscle, so that when we add the proteolytic enzyme, the enzyme can penetrate easier into the meat, into the muscle. And that's going to get a little bit noisy, but for... That's okay. And we already have a pre-homogenized one, right? Okay. So once... You can probably stop it now. So once we have a homogenate, what we do is we place it in a water bath to keep it at a constant temperature. And I think we have one over here already. We're like... Is it in here, Jason? We will place it in a water bath, allow it to reach a constant temperature. In this case, because of the nature of the enzyme that we're using, we're going to try and make it come up to 50 degrees Celsius. Once it's reached that temperature, we will add a proteolytic enzyme. This enzyme, what it does is it's going to break down the protein in the muscle, in the fish muscle or meat, break it down into smaller fragments. The longer we leave the enzyme in contact with the fish muscle, the more fragments that we'll obtain. The protein will be broken down into smaller pieces. So based on the time we use for exposing the enzyme to the substrate, and in addition the type of enzyme that we use, we can obtain different types of protein pieces or chunks that have different properties. And that's where the research starts getting interesting. So this is just the preparation stage, very monotonous. Once we have the enzyme with our substrate, which is the fish muscle, we obtain a hydrolysate. At this point it will be called a protein hydrolysate. We centrifuge it to separate the proteins from anything else that was in that muscle, so that we can obtain a more pure sample of protein, of fish protein. And the protein hydrolysate, which is what we obtained, gets dehydrated or freeze-dried, so that we remove all the water from it and we just obtain a water powder form of the sample. That is really what is a protein hydrolysate or fish protein hydrolysate. We use these hydrolysates in the industry. They can be used as food ingredients that can have foaming capacity, as foaming agents, emulsifying agents. They have been used, for example, also for nutritional beverages or sport beverages to increase the protein content in them. But also, more recently, a lot of these protein hydrolysates, including the ones that are obtained from fish, have been shown to have bioactive properties. That means that they have shown to lower blood pressure or to have some form of antihypertensive properties. They've also have shown to be good antioxidants. And some studies are even suggested that fish protein hydrolysates could be used to lower cholesterol. So there's a lot of potential for maximizing the value of products that will otherwise be discarded, which is the case of the Asian carp as an invasive species here in the U.S., to use this product that is being discarded, obtain a value-added product out of it, which is what we call the fish protein hydrolysates, and use those hydrolysates as either ingredients in the industry or as bioactive agents that could have some health benefits at the end of the road.
Now, a lot of people say eating fish is good for you. In America, we don't eat as much fish as other parts of the world. This is considered a delicacy in some other parts.
In Asian countries, this type of fish it's a delicacy, and it's cultured and processed into many different types of products, including eating as is. But I believe also in some European countries they consume it as well.
And so there's a lot of science involved in this. A lot of people at home may not understand that. What they might think is you're probably just cutting it up into pieces and trying to cook it different ways. Has that been tried yet?
No, not for us. We'll leave that to the consumer. We are trying more to see how we can actually, as I said, add an enzyme, get the protein out of the product, out of the meat, and create a value-added, protein-enhanced product that can be used more for the food industry or for health benefits.
Not per se on a restaurant table.
The hydrolysates, not necessarily. No. But I mean, the fish as it is, I mean, it's good quality fish. It's a delicacy, as you mentioned, in other countries, and I don't see why we shouldn't give it a try.
Do you think it's just because of the stigma here in America, especially? Oh, it's carp.
Because it's carp, and also because I think we're associating, there's a negative connotation that it's an invasive species, so maybe there is some negativity towards accepting a product that we know it's an invasive species in U.S. waters.
But if you were to look at this without a head on it, and
maybe I wouldn't even know that it's a carp or an Asian carp for that matter.
Yeah. The flesh, from what we saw going in, looked like maybe a striped bass or something like that.
That's right. And this hydrolysates can be obtained with any type of fish. But in this case, we want to use an underutilized species.
Does it compare to any other fish you've worked on?
That's the type of research that we're carrying on right now, comparing hydrolysates from different types of fish sources. I've worked with herring, with Pacific whiting. We've done some with yellow perch, and now we're trying Asian carp.
Okay. And to this point, is it too early to tell if it's like any others, or what sort of value it might have? Right
now it's too early, but probably in about 2 or 3 months we'll have some more concise results.
You're pretty excited about this work. Obviously it's been in the news a lot. A lot of people may not know that behind the scenes right here in their backyard there's work being done, you know, even though a lot of people may just kind of want to turn the other cheek perhaps and not admit that this could be a problem. You're one of many people trying to find a solution to do something with it, because probably not getting rid of them anytime soon.
I mean, from what I've heard and what I've read, it's an invasive species. It's a great concern. It's nearly impossible to get rid of it, 100% get rid of it. And from what I've done for over the last 10 years is try to increase the value, the commercial value of either underutilized species or byproducts from the fishing industry, and just try to commercialize materials that will otherwise be discarded. So how can we create a more sustainable environment around us? Well, that doesn't sound bad. That we work with for testing, for adding them. What will happen if we add amounts of this